Talking Heads and Open Human Frameworks examines pipelines for animated conversational agents, beginning with 3D models, rigging, and speech integration to produce talking heads. It introduces the Open Human Framework, which links bodies and heads to brains and AI for integrated embodiment. The section also emphasizes anthropomorphization as the connecting principle across chatbots, virtual beings, and robots, showing how human-like traits are projected onto different technological forms. This diagram, titled Talking Head Diagram, illustrates the pipeline for creating and animating a virtual talking head. The process begins with uploading a 3D model, which is then rigged, facial and automated rigging, to prepare it for animation. The system integrates with services like speech-graphics.com to handle synchronization, linking rigging to speech-driven facial animation. The speech module processes both speech input and speech output, enabling the talking head to listen and respond in real time. Inputs can come from a human, via voice, or from a chatbot API via text, which the system converts into spoken responses. The entire workflow runs within different environments, mobile, web, or engine, enabling deployment across platforms. Together, this shows how 3D avatars can be transformed into interactive talking heads that combine visual animation with speech recognition and synthesis. This diagram, titled Open Human Framework, illustrates a conceptual structure for building virtual humans by integrating bodies/heads on one side and brains/AI on the other, with a central connecting layer. The middle box, marked with an X, represents the framework itself, which acts as the bridge between the physical or graphical representation of the virtual human, its body and face, and its intelligence or cognitive system, AI for decision-making, interaction, and behavior. This highlights the need for a unifying architecture that links embodiment and cognition, ensuring that virtual humans function as cohesive, lifelike entities rather than isolated technical components. This diagram shows the continuum of anthropomorphization across 3 domains: chatbots, chat robots, virtual beings, virtual robots, and hardware robots, physical robots. Chatbots represent the most text or voice-based, disembodied form of interaction, while hardware robots represent physically embodied machines. In between, virtual beings occupy a hybrid space as visually embodied but digitally existing agents, bridging the gap between chat-based AI and physical robots. The arrow above indicates a progression. As systems move from chatbots to virtual beings to hardware robots, they take on increasingly human-like traits in form and behavior, deepening the anthropomorphization process. On the left, anthropomorphism refers to giving non-human entities human-like traits, such as human faces, voices, gestures, or behaviors, to make them more relatable and understandable. This is often the foundation of how virtual beings are designed, helping users perceive them as social actors. On the right, personalization represents a further step, where the virtual being adapts specifically to an individual user's preferences, needs, and context, creating a tailored and meaningful interaction. The overlap in the middle suggests that many systems combine both strategies, blending human-like qualities with adaptive, user-specific behaviors. The arrow pointing right indicates a progression toward increasing personalization, highlighting a design trajectory where virtual beings evolve from generalized human-like representations into more intelligent, context-aware, and personalized companions. This diagram compares pathways for creating 2D and 3D talking head videos, distinguishing between asynchronous and synchronous processes. In the 2D workflow, synthetic media begins with text input, which drives facial behavior to generate a 2D talking head video, typically asynchronous and pre-rendered. In the 3D workflow, a 3D model is combined with speech input to animate facial behavior, producing a 3D talking head in VR, which is synchronous and real-time. Both workflows can loop back to generate 2D talking head videos as asynchronous outputs. The comparison highlights how input modality, text versus speech, and dimensionality, 2D versus 3D, influence whether the resulting virtual head operates in real-time interactivity or as pre-produced synthetic media. This diagram, titled Neural Transduction, illustrates the bidirectional process of converting between text, speech, and facial behavior in virtual beings. In the top sequence, text is transformed into speech, which then drives facial behavior, enabling avatars to animate speech visually. In the bottom sequence, the process reverses. Facial behavior is interpreted into speech, which can then be transcribed back into text, representing recognition and analysis of human expressions. Together, these flows show how neural systems mediate between verbal and nonverbal modalities, enabling both the generation and interpretation of communication in digital humans. This diagram depicts the internal structure of a virtual human, organized within a cognitive architecture that coordinates different subsystems. At the top, a state machine manages decision-making and flow of actions, linking to both the behavior realizer, which controls nonverbal communication such as gestures and expressions, and the dialogue system, which manages verbal interaction. The dialogue system further connects to RPA, robotic process automation, enabling automated execution of tasks and responses. Together, these components ensure that a virtual human can both converse and act in ways that appear coherent and lifelike, with the state machine orchestrating interactions across verbal and nonverbal modalities. This diagram shows the progression of conversational agents toward increasingly embodied, virtual beings. It begins with chatbots, which are text-based systems relying on written input and output. The next stage is voice bots, which expand interaction into spoken communication, making the exchange more natural and human-like. At the highest level are digital humans, avatar-based entities that combine text, voice, and visual embodiment to simulate full human presence. This progression illustrates a continuum from disembodied interaction to fully embodied virtual beings, highlighting how advances in modality and embodiment enhance realism, social presence, and user engagement.